right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Warm-up number 37 is on the screen. Get started, please, and then I'll come right after to do a couple of those just to introduce or scaffold some of the things that we're going to be looking at starting this coming Wednesday and Thursday. We're already getting started with graphing. Let's go. Let's go. So copy that and go. All right, here we go. Warm-up number 37. For the sake of time, today we have a bunch to cover, and we're about to move on to a new concept since we're already done with expressions. Come on, Pew. Really? Oh, yeah. We got this. Here goes number 1. Now, hopefully, your brain, your noodle, kicked in and you remembered how to write your inequalities for this one. So first thing you should have checked, since there's two different inequalities there, they're overlapping. Is that correct? So what kind of inequality is this? This is known as an and. Good morning, thank you. All right, so if it is an and because they're overlapping, we just need dividing points. What's my first dividing point over here? -1. How about over here? 1, 2, 3, 4. So I'm going to write -1 and 4. So the shaded region, which is this, represents the variable. So what do I write in between? X. And then arrows to the left between X and the dividing points. What else did we check for? Well, look at this point right here. Is that a solid point? Yes. How about this one? Yes. So if it's a solid point, we put an equal sign and an equal sign. Then we just write our solution set. Solution set of X such that, and we close that. Is it coming back for some of us? Yes? Yeah, because we're rapidly approaching graphing, and I already gave you all these skills on the warm-ups and prior to this with other review from Algebra 1. Hopefully this is piece of cake by now, yeah? Let's go to number 2. Number 2, it says solve. So, question, is this a proportion? Tell your neighbor what a proportion is. See if they remember. What is a proportion? Yeah, a fraction equal to another fraction. Is this a fraction equal to another fraction? No, because we have more fractions over here. So this is not a proportion. We can't cross multiply. So what do? I need to multiply the entire equation times the common denominator. What's our common denominator for 3, 6, and 9? Tell your neighbor, common denominator for 3, 6, and 9. Yes, 18. So we distribute that here. 18 times 2x is 36x over 3 plus 18 times x, that's 18x over 6 plus 18 times 1 is 18 over 6. And 18 times -2, that's negative 36 over 9. All right, next, simplify each fraction. This becomes 12x. This becomes 3x. This is 3. And this is -4. From there, combine like terms. So we can combine these two, and that becomes 15x plus 3 equals -4, minus 3 minus 3, 15x equals -7. Last but not least, divide by 15. X equals -7 15. Woo-wee. Is it coming back? Yes, some of you? You're like, oh yeah, Mr. K, I remember these at the beginning of the school year. Yeah, like the second week and the third week we did these. If you go to your notes, they're going to be in there. Okay? And let's go to the last one, number 3. And by the way, I don't know if you noticed, these we also covered the second week and the third week. They're all coming back. That's why I gave you guys plenty of practice. So your noodle has it in there. We just need to retrieve it again. Let's go to the last problem on the warm-up, number 3. Now, I hope you notice something different about this one. So you never, what's different about this one? Yeah, I made it kind of obvious, yeah. F of x, yeah. Yeah, Before it was what? Before it was just a y. But now we're replacing it with f of x. Why, Mr. Q? Because now I want you to understand that this is known as a function. That's why we use the f of x. Now, what does that mean, Mr. Q? That means we're very close to using all this stuff, but I'm baby stepping you to get there. So we're going to evaluate first. Last week and the previous week we did it in our noodle. Today we're going to do it here on paper. Here we go. So check this out. First things first, I need a table for my domain. What is my domain? My domain is -2, -1, 0, 1, and 2. Okay. And what do we need to find? We need to find our y. But instead of y, what do we have now? F of x. Very good, because I just said that instead of y, we have f of x. All right, so to get f of x, we're going to evaluate. That means we're going to substitute values in here, but this is how we're going to do it. Write your utensils down, look at the screen. Now, this, hopefully, when you got to Algebra 1, your teacher showed you how to do this part, but I'm going to go over it one more time. Here we go. Thank you, Mr. Q. You're welcome. Here it goes. F of 2 times. Now look up. What did I do? I replaced the x's with empty spaces. Why? Because I want to substitute here my domain. What is my first value for the domain? -2 and -2. This is where some of you got confused. Look up. In the past, some of you saw f and then parentheses -2. You thought it was multiplying, and you got rid of the negative. That's not correct. This side is only a label. A label. That's just a label saying I'm working with the function of -2. That's all it says. It's not anything that we solve on the left side. So if it's just a label, I'm going to rewrite it again and again, just to let me know what am I working with. So that leaves me only to work on the right side. So here we go. What is 2 times -2? -4. Bring down the -1. What is -4, -1? -5. And that goes right there. Copy that, please. All right, let's do it again. F of 2 times, but now the next value that I'm going to substitute is what? -1. -1 here, -1 here. So what do I write on the left side? I write it 2 times because it's just a label letting me know what I'm working with. So on the right side, what is 2 times -1? -2 minus 1. What is -2 minus 1? -3, and that goes right there. Let's do another one. F of 2 times -1. My next value is what? 0. Left side is the label. I just write it twice. And I'm going to work on the right side. 2 times 0 is 0. -1. What is 0 minus 1? -1. All right. We got the last two. F of 2 times F of 2 times. I'll let you do those two, and then I'll ask Ivan to help us out. All right? I'll give you some time for that. Go. All right, here we go. So what's my next value? My next value is what, Ivan? One. That is correct. 1 and 1. So what do I write here? Yes. Here? Yes. So we write it twice, okay? So tell me what is 2 times 1? -1. What is 2 minus 1? Yep, and that goes right there. Thank you. Fredo, next value. What do I substitute? 2 and 2. So I write F of 2, F of 2. So 2 times 2 is, -1 is And that goes right there. Hands if you got that by yourself. Okay, good. Let's graph this. All right. So this we know is our x, and this we know is our y, but now instead of y, what do we have? F of x. Yes, that is correct. All right, so let's graph this. First point is -2, -5. -2, 1, 2, 3, 4, 5. Next one, -1, -3. -1, 1, 2, 3. Next one, 0, -1, 0, -1. Next one, 1, 1, 1, 1. Next one, 2, 3, 2, 3. We graph this. Nice and straight like mine, going through each of those points. Arrows at the end. We label this f of x so that we can refer it back to that. All right, good intro to functions, yes? Soft introduction, yeah. Thank you, Mr. Q, for giving us plenty of practice with y equals to something and the graphing. You're welcome. I got you. Let's go. Agenda for today, warm-up number 37, rational functions, and we're moving on. No more rational expressions. We got this. We got this. Oh, yeah. Play sheet number 10.7b is in Canvas. I uploaded a new module titled Rational Functions, so you're going to find it in there. And, yeah, we're moving on, guys. Rational functions, we're going to be done between today and tomorrow. Tomorrow will be our last day. Wednesday, we have minimum day, and we're going to start our graphing portion. Woo! So, everybody say graphing, because that's going to be the rest of the year, guys. Yeah. Graphing is the word. Tell your neighbor the word. Yeah, graphing, the rest of the year. Let's go. That's why part of your materials was what, Jaden? To get what? Aside from the 4 colored pen. Graphing paper, yeah, your notebook, yeah? Go ahead, one. Yes. All right, what's that? Warm-up number 37, rational functions, play sheet 10.7b, numbers 1 through 10. All right, get a Cornell note ready, please. And you do need a Fair model. I'll give you a minute to do that. Oh, and before I move on, just so that it's recorded here, ready? Here goes. And everybody pay attention to this part. Parents, you can come back and hear this in the video. Since we're starting now with more complex concepts and skills, I need everybody's mobile devices put away, including pods. If I see somebody with them out from this point forward, and I haven't asked you to get them out, I'm going to pick them up. I'm not going to argue with you or anything back and forth. I'm just going to call you, bring that to me, send it over to the office. You can pick it up with your parents later on. Okay? Fair warning? Fair warning? Yes? Have I been pretty lenient about that? Yeah, right? Okay? However, now that we're getting to the part where it's the meaty part of this course, I need you guys to stay focused. That means if you are distracted by your iWatch, take it off. Without saying any names. All right? So with that said, I can solve rational equations. I can solve rational equations. I can solve rational equations. What's our major concept for today? Tell your neighbor, please. Yeah, rational equations. So therefore, in your Fair model, write that in. Rational equations. What are they? Definition. They are equations that contain one or more rational expressions. Now, you're like, that sounds kind of familiar, Mr. Q. Yeah, because the word rational expression should kick in your noodle, because all last week and the previous week I kept saying, tell your neighbor what a rational expression is in your own words. Is that correct? Did I say that? Yeah. Yeah. So rational expression, before you we go over the example, tell your neighbor what a rational expression is in your own words. Rational expression. Rational expression in your own words. All right, good conversations. Fredo, pass them one. Okay, Fredo, what are rational expressions? In your own words, what do they look like? Yeah, polynomials. What else is so particular about rationals? Yeah, polynomials, but where? Numerator and denominator. So that means fractions with polynomials. That is correct. So let's look at this definition according to now the new concept. Rational equations are equations that contain what? One or more rational expressions. Can you picture it now? Yes, here go the examples. 6 over g plus 4 equals 2. 2x minus 14 over x squared minus 15x equals 1. And 2x plus 6 over x squared plus 5x plus 6 equals 1 over x plus 3. All those three are examples of rational equations. Now, once again, as you're writing those down, according to the definition, rational equations are what? They are equations. Let's see. Do we have an equation here? Yes. Here? Yes. And here? Yes. Do each of them have at least one or more rational expression? Let's see. Do we have a fraction with polynomials on the first one? Yes. How about the second one? Yes. How about the third one? Yes. All of these are rational equations. Okay. Pretty straightforward, yes? All right. So before you copy the non-examples, look up. Show your neighbor why the first two non-examples obviously are not rational equations. Tell your neighbor, please, why are these first two not rational equations? All right, let me pick Ivan. They don't have an equal sign, of course. They need to be equations. How about this one? Why is this one not a rational equation? Anaya, what do you think? No fraction. That is correct. It needs a fraction with polynomials, so therefore that is not. So what would be an obvious hashtag, guys, between what rational equations are? It has to be a what? An equation, yeah. So hashtag equation. And the second one will be hashtag at least one rational expression, at least. You all right over there, Valente? You warming up? All right. Oh, let's go. Right? I'm telling you. So, Valente hit it right on the mark. He said, I'm warming up, Q, for what's coming. Let's go. So copy these steps, guys, for real. Here we go. Step 1. So, if or when the rational equation is a proportion, comma, then cross multiply and solve. Have we been doing that on the warm-ups? Yes. When a rational equation is a proportion, cross multiply and solve. So just to verify, do we remember what a proportion is? Yes, a fraction equal to another fraction. That's it. Not two fractions equal to another fraction. No, it's one fraction equal to another fraction. Okay. So what do? Cross multiply and then solve. Yeah, I think we practiced that. But hence the question, Mr. Q, what if they're not proportions? What do we do then? Well, you do these next steps. First, identify the common denominator. Second, you multiply the entire equation by the common denominator. And lastly, you simplify and solve, which is basically what we've been doing also with some of those equations. Yes? Yes, Mr. Q. I'll give you some time to copy that. Copy and... All right, just to double check. Step 1 says when the rational equation is a proportion, cross multiply. Once again, what is a proportion? One fraction equal to one fraction. Okay. If it's not, then we we identify the common denominator, which we did on the warm-up, multiply the entire equation by the common denominator. From there, we simplify, and then we solve. Okay? Valente, you all warmed up? All right, example 1. Copy this, please. We got 5 over x minus 2 equals 3 over x. And the instructions are solve algebraically and identify excluded values. Oh, yes, they're back, baby. Let's go. Excluded values. So, by looking at it, tell your neighbor, is this a proportion, yes or no? Why or why not? Talk it with your neighbor. Is this a proportion? Yeah, good conversations. Who haven't we picked in a while? Valente, is this a proportion? Close. Do we have one fraction equal to one fraction? Look up, look up. One fraction bar equals to one fraction bar is a proportion. All right, so since we do have a proportion, check this out. I'm going to start with the smallest values, cross multiply. What is 5 times x? 5x, write this down, equals, like I said, we already did this before. I'm just going over it one more time, but now with the process. Next, 3 times this binomial, that means I need to multiply 3 times x and 3 times negative 2. So that gives me 3x minus 6. So, step 1, done. Now, I don't need to do steps 2 or step 3. I go straight to the last step, which is simplify and solve. So, therefore, I need all variables to one side. Jaden, go. What do? Thank you. Subtract 3x, subtract 3x. We're left with 2x equals negative 6. Last but not least, we divide by 2. X equals negative 3. Ooh-wee. You're like, this is easy. Yes, because we've been doing this all year. Since second week. Come on, peeps, let's go. However, are we done? Excluded values. Let's see if your neighbors remember from last week. How do we identify the excluded values? Talk it over to your neighbor. How do I identify excluded values? What do I do? All right, I think Ivan's got this. Go. Denominators equal to 0. That is correct. So I'm going to write x minus 2 equal to 0, and then the other one is x equal to 0. Yes, this one's already solved. This one I add 2 to each side. X equals 2. Those are my excluded values. From 1 to 5, I'll confer you with this. 5, 5, 5, 4. We got it, right? All right, let's see if you can do this next one by yourself. It's almost exactly the same. You just follow the process. Here we go. Example 1Q, 1 over x equals 3 over x plus 4. Copy that and go. Check your work on the screen. Cross multiply, solve for x equals 2. Set each denominator equal to 0. I'm going to highlight it so that you see it once more. This denominator equal to 0 and this denominator equal to 0. Oh. That denominator equal to 0, and so on and so forth. From 1 to 5, I'll provide you with these. Yeah, 5, 5, 5. Yeah, we got this. Yes? Crank it up a little bit. Yes? All right, here we go. Example 1 supercube. Copy this. X plus 1 over x minus 2 equals 4 over x minus 3. All right, before I get started, tell your neighbor if this is a proportion, yes or no, why or why not. Is that a proportion? All right. Juan, is that proportion? Yes, why? I'm sorry? Which way? The equal sign, okay, that makes it an equation, but what makes it a proportion? 1 fraction bar equal to 1 fraction bar. Do we have that? Yes. All right, so cross multiply. I'm going to start with the smallest value, which is 4. If I distribute that to these two terms, what do we get? 4x minus what? 8, yes. equals. Now check this out. This is where it gets interesting. Now we have a binomial times a binomial. That means this one times this, but the whole thing. So I'm going to write them out so that you can see it. X plus 1 times x minus 3. Do we know how to multiply these two? Yeah, distributive property. You guys want to use distributive property or area model? What do you guys? Distributive property? All right, here we go. What is x times x? X squared. What is x times negative 3? Negative 3x. What is 1 times x? That's 1x. What is 1 times negative 3? Negative 3. Can we combine like terms? Yes, these two right here. So that leaves us with x squared. Then we got negative 3 plus 1, that's negative 2x. And bring down the negative 3. And all that equal to 4x minus 8. Woo-wee. So no longer do we have a rational equation. Now we have a different kind of equation. What kind of equation do we have? One that has a higher degree of 2. What is that called? A quadratic equation. What do we need to do to solve a quadratic equation? It needs to be equal to what? Tell your neighbors here if they remember. To solve a quadratic equation, it needs to be equal to what? It needs to be equal to, what do you think, Alex? It needs to be equal to what to solve a quadratic equation? Okay, fair enough. Christina, equal to what? That's 2. Jessica, what do you think? It needs to be equal to 0. Remember when we did the square roots, when we did the graphing and all that? It needs to be equal to 0. So let's make this side 0. What do I need to do to make this side 0, guys? Yeah, minus 4x and plus 8. Minus 4x and plus 8. That means this side becomes 0, and we're left with x squared minus 6x plus 5. All right, this should look familiar. Look at it. Before I call on Steve, look at it and tell your neighbor, what do I do from there to continue? What do I do from here? Talk it over to your neighbor, please. We got it? Yes? All right. Steve, go. What do I do? Yes, we solve it, but what do I do to this trinomial? Okay, help him out, Alyssa. The 5 and the negative 6. What factors of 5 add up to negative 6? Factors of 5 add up to negative 6. Jaden. Negative 5 and negative 1. That is correct. So my factors are x minus 5, x minus 1, and all that equal to 0. Next, tell your neighbor what would be the next thing to do. We practiced these. We did these. Tell your neighbor what else do we do from there. Christopher, go. What do I write? Julian, help him out. So what do I write? Let's go from the corner. That is correct. Set each one equal to 0 and solve. Plus 5 plus 5, x equals 5. Plus 1 plus 1, x equals 1. And we're done. So if you notice, we started with a rational, cross-multiplied, we ended up with a quadratic. What is so important about quadratic? It needs to be equal to what? 0. From there we factor, and the rest is history. All right, are we done though? No, excluded value. And Ivan's going to tell me what to write before he steps out for a little bit. What do I write? All right, so what do I write? Equal to 0. Let's go. Plus 2 plus 2, x equals 2, plus 3 plus 3, x equals 3. From 1 to 5, how comfortable are you with this so far? 4, 4, 4, 4. Okay, we need practice. Okay, I'm going to give you one almost exactly the same. Should be able to do the whole thing. Ready? Yeah. Here you go. Example 1. Is it mega Q or? Yeah, 1 mega Q. We got 8 over x plus 3 equals x plus 1 over x plus 6. Copy that and go. I'll give you some time. And go. All right, get it started, Joel. Oh, what? What timing, right? We'll have plenty of time for him, right? Yeah, okay. All right. Continue, Jalen. What do I do? Uh-huh. Yeah, I'll write it out first. And then you said x squared. Which becomes x squared plus. Uh-huh. Hands, have you got up to right there? Okay, continue, Diego. Let's go. Continue, Briseida. Power Rangers, negative 45 and negative 4. Negative 9 and 5. So what do I write? 0 equals to what? X minus 9 and then x plus 5. Let's go. Oh, 5. All right. So let's continue this row. Isabella, what do I do from there? Yes. Yes. So far so good. Hands, have you got it up to right there? Yeah. Oh, Dylan, go. And add 5. Oh, subtract 5 to both sides. Okay. X equals negative 5. Hands, have you got that by yourself? Okay. Excluded values. Anaya, what do I write? So therefore, minus 3 minus 3, x equals negative 3, minus 6 minus 6, x equals negative 6. Hands, have you got that? Yeah, from 1 to 5, how comfortable are we? Yeah? Okay. So, we got this, yes? All right. Example 2. Copy this. 6 over x plus 2 minus 10 over x equals 4 over 2x. All right. So before we continue, look at the equation given and tell your neighbor if that's a proportion, yes or no, why or why not. So that means what? Is that a proportion? Caleb? Close. Remember, a proportion is 1 fraction bar equal to 1 fraction bar. And what do we have here? 2 fraction bars equal to 1 fraction bar. So it's not a proportion. So if that's not a proportion, that means we don't do step 1. So where do we go then? We go to identifying the common denominator. So I want you to go to the far right of your paper, and I want you to write LCD. We're going to first find the common denominator for all three denominators. My first denominator is what? X plus 2. My other denominator is x, and my third denominator is 2x. So, let's start with the smallest ones. To make these two look the same, or to have a common denominator for these two, tell your neighbor what we need to do. What do we need to do for these two to look the same? Close. Let's see. I'm going to call Lorena. To make these two look the same, what do I need to do to one or the other? You multiply it. Which one do you multiply? Times. Yeah, that is correct. Times 2. So my common denominator for these two is 2x. All right, let's bring down the other denominator. So now we only have two denominators. We have the common for these two and this one. Question, is this in standard form? Yes. Is there a GCF? No. So, parentheses. This one, standard form, yes. GCF, no. Parentheses. So, to make these two common denominators, that means I need to multiply this side times what? Yeah, x plus 2. And this side times what? 2x. That is correct. So that means my LCD for all of them is 2x, x plus 2. Yes? We're done with step 2. Let's go to the next step. What does it say? Multiply the entire rational equation by the LCD. All right, so here we go. Multiply the entire equation. What was my LCD? 2x times x plus 2. 2x times x plus 2. Okay, here we go. I'm going to do the first fraction. Here we go. This times the numerator. I end up getting, watch, check this out. I rewrite the fraction pretty much, and then I multiply only the numerator times what? 2x, x plus 2. Minus. I need to do the next fraction. Distribute that to the next one. So what do I write? 10 over x, but the 10 we're going to multiply times what? 2x, x plus 2. Equals. With that said, tell your neighbor what to write for the last fraction before I call Joel to help us out. The last fraction, what do I write? Yeah, good conversations. All right, bless you. All right, so the last one, we need to distribute to the last one. So, what do I write here? Go, Joel. The 4 times 2x, x plus 2, over 2x. Hands, if you got that? That is correct. So basically, we keep all the things the same. The only thing, each numerator times the common denominator. Now check this out. I'm going to go one step here because this is a subtraction. This needs to be what? Addition. That means we distribute that to the 10. So I'm going to write 6 times 2x times x plus 2 over x plus 2. And then we have negative 10 times 2x times x plus 2 over x equals 4 2x x plus 2 over 2x. So I'm done with step 2. I'm going to step 3. Simplify. Tell your neighbor if you see the giant ones from there. Do you see the giant ones from there? Let them know which ones they are, please. All right, help us out, Alessandra. What's the first giant one? X plus 2. That is correct. What would be our next one, Delilah? All right, she said she went all the way over here to the 2x. Okay, there it is. We're missing one more. One more. Frida. The last one. About the x's. Why am I able to do that here, guys? What's here? Isn't this multiplication? Yes. Why didn't I do it on this one? Because there's addition. So therefore, we're left with 6 times 2x, that's 12x, plus, what's negative 10 times 2? Negative 20. And then we distribute to here. That gives us negative 20x minus 40 equals, next, what is 4? Distribute here, that gives us 4x plus 8. Do we know what to do from there? Yeah, let's continue. Combine like terms. Negative 8x minus 40 equals 4x plus 8. And the rest is history. Get all variables to one side and solve for x. All right? Your home plate tonight, once again, is in Canvas. Go to the rationals function. Placey will be in there. Have a good one, guys. See you guys tomorrow. Bye. Let me finish this. Negative 4x, negative 4x. That is negative 12x minus 40 equals 8 plus 40 plus 40. Negative 12x. Negative 12x equals 48. Divide by negative 12. X equals negative 4. Woo-wee. Bye.